Our next speaker in this session is Dr. Barbara Wienecke, who is talking to us about the long-term status and trends of emperor penguins with the caption, "Loss of an Antarctic Icon." Barbara is an internationally renowned seabird ecologist who's been studying the foraging ecology of penguins and other seabirds for more than 20 years. Her work really focuses on population dynamics of the emperor penguin and the factors driving their change. She also has a keen interest in Antarctic history and is an enthusiastic member of the Australian Antarctic Names Committee. Barbara can't join us in person today, so we're going to hear Barbara's presentation virtually.
Hello everyone. Most Antarctic seabirds breed on ice-free land in summer. But emperor penguins are the exception, as their colonies form in winter and occur mainly on the frozen ocean surface or fast ice. The fast ice forms a narrow, discontinuous band right around the continent, and in some locations, conditions are suitable for emperors. Since these birds incubate their eggs on their feet, they need a flat surface, and they also need the fast ice to persist for at least 9 months to raise their chicks. The first ever emperor penguin was probably seen in 1821 on von Bellinghausen's expedition, but the first 2 breeding sites were discovered only 81 years later. We now know of 60 extant colonies that vary in size from a few hundred to over 20,000 breeding pairs. 22 of these colonies occur in the Australian and Arctic territory. It took 117 years to find these 60 colonies. Around the time of the International Geophysical Year in 1957-58, the 8 colonies discovered nearly doubled the number of then known colonies. And when very high-resolution satellite imagery became widely available about 50 years later, more colonies were found. In 2019, the last 8 colonies were detected. Thus, getting a good estimate of their abundance, let alone a trend of the global population, has been a bit of a challenge. Many colonies have never been visited, and we don't know anything about their size, let alone their trend. Long-term population data exist for only few colonies, but all of them have shown significant change over time. Recent catastrophic events affecting populations have at times been spotted from space. For example, at Cape Crozier in late November 2018, the colony was in its traditional spot right next to the Ross Ice Shelf. But in December, a big storm destroyed pretty much all the fast ice, most of the colony area, and about half the chicks. We need to understand where and how often these events occur. Similarly, in the Weddell Sea, Halley Bay, with 22,000 pairs, the second largest colony, suffered complete breeding failure 3 years in a row. Early ice breakouts occur elsewhere, including in the AIT. But these 2 examples here are particularly important because both are a long way south and occur in suggested climate refugia. Current models predict significant losses of colonies and reduction in the global population. Even under the least damaging scenario, 32 of the 60 colonies are expected to become quasi-extinct by 2050. That means they will be too small to recover. In light of recent events, the notion of climate refugia in the Weddell and Ross Seas really needs to be tested further. While we can learn a lot from satellite images, ground visits provide information that cannot be gained from space, especially in winter. For example, in May 2009, all appeared well at Oster, as large numbers of penguins had gathered. But just 2 weeks later, ice breaking off a nearby iceberg caused significant disturbance and major egg losses, and many birds left well before the season was over. Seabird colonies are diverse and may respond differently in similar situations. For example, at Point Geologie, breeding success was high when open water was only 20 or 30 kilometers from the colony, but decreased significantly when it was more than 50 kilometers away. In comparison, at Taylor Glacier, breeding success also varied dramatically, but the penguins always travel around 70 kilometers. This shows that other factors clearly also affect breeding success. Because of their critical dependence on fast ice, climate change is the most serious threat to emperor penguins. Change in the Antarctic environment is not unusual, but concerns arise when the frequency, magnitude, and geographic spread of harmful events increases, making adaptation so much more difficult. We need to identify strongholds and assess which populations are decreasing least. Reduced human impact and more protection, for example through protected areas, may help sustain the species. There are now calls in the international community for the species to be listed as vulnerable to extinction, and our data certainly support that. We need a comprehensive approach and international collaboration to monitor a wide range of colonies to understand the drivers of their global population trajectory. The more colonies we can monitor, the better the refinement of population models and predictions. Thank you very much.